In this demo, we're going to take a look at a RabbitMQ producer-consumer application in which the Rabbit messages will be persisted into Postgres backed by persistent external storage. And how we achieve the persistent external storage is by leveraging RexRay and Mesos module DVDI. If we take a look at the Marathon UI, we'll notice that we have a number of tasks already running. The first one's Mesos DNS, which is a task discovery service that allows tasks within Mesos to find each other. And then next we have Postgres, so a Postgres database, and this has external persistent storage attached to it to house the SQL data. And since all this stuff is hosted on Amazon EC2, if we take a look at the volumes, we have a Postgres volume here, so standard Amazon EBS volume. The next thing we have is RabbitMQ. And RabbitMQ is just a message bus that will allow the consumer and producer to talk to each other. And then last but not least, we have the Rabbit consumer, which will take messages from the Rabbit server that were created by the producer, and it will take that message, persist it into Postgres, and then send a reply back. And how we can visualize all this stuff is I created a simple web page on the consumer that will show the messages that have been received from the client. And we can see the page is loaded, but since we don't have any messages being generated by the producer, we don't have anything on the page here. Next thing we want to do is take a look at the Postgres database itself. So we need to identify what Mesos agent node the Postgres database is on. And we do that by looking into the details for the database. And then we want to open up the database, so we're going to do that using pSQL, which is a standard Postgres command line utility. We're going to open up the database called demo, list the tables within this database. There's only one, it's messages. And then we're going to select all the messages from the table and find out that there aren't any, again, because we haven't produced any messages yet. But here we see the table structure. So we're going to record, for every message, we're going to record the client that sent this message, the unique ID of it, and then we're going to record the message that was sent by the client. We're going to record the message that is going to be created by the consumer in reply to the producer. So the next thing we need to do is we need to create a Rabbit message producer. And how we do that, we're going to curl a JSON file to the Marathon REST API, and that should create us a Rabbit producer. So let's go ahead and do that now. When we go back to the Marathon UI, we'll see the Rabbit producer being deployed. And then now it's in the running state. And then if we go to that web page, we should see the client and the messages that are being sent from that client to the consumer. And then if we go to the database, back to pSQL, we'll notice that here are the messages that the consumer has received. And then in reply, the messages that are sent back to the producer. So now we want to simulate a failure in the data center. So we want to fail the Mesos node that owns the database layer. So to do that, we're going to need to look up where the database currently is. And we're going to have to go to Amazon, to EC2, and find the instance, find the Mesos agent node that is holding onto this database. And what we're going to see is this database fail, move over to a new Mesos agent node. That persistent storage, that EBS volume, is going to follow that workload, so that database to the new node, and it's going to come back up with all of the data that has been saved. So we're not going to lose any data. We're going to basically recover this database and pick up right where it left off. So let's go ahead and simulate the failure by killing the Mesos agent node. If we go back to Marathon, we see that the Postgres database has died, and then also the Rabbit producer, it just happened to be on that same node. And it looks like the Postgres database is fully online again. So let's go ahead and turn back to pSQL. Actually, first we need to find out what host the database is on now, since it had failed over. And then we're going to go back to pSQL and then relog back into the database. And there we go. We saved all of our data. We failed over to the new node. All our data is there. None of it's missing. And in summary, external persistent storage can help accelerate your recovery times when you have failure in the data center. And more importantly, it will take your existing application, your existing workload, and make it highly available and fault tolerant.